Welcome to Mickey Study Circle channel. In this video, we shall see how to do the manual drafting of the orthographic projection of solids. So we'll take up a problem on square pyramid. In the previous video, we saw how a square pyramid resting on one of its slant edges with one of its axes is inclined to VP is drafted. Now we'll consider the condition wherein a pyramid is resting on one of its slant triangular faces. So the initial condition is not given, but however, the second position is told that it is resting on one of its triangular face. So for this condition to be achieved, it is possible only if initially it is resting on one of its base edges, and then it could be rotated in such a way that it is resting on one of its slant triangular faces. So now let us see how to do the drafting. So the condition goes like this. So we have a square pyramid of 35 mm sides of base and 60 mm axis length resting on HP on one of its slant triangular faces. Draw the projections of the pyramid when the axis is inclined to VP at 45 degrees. So now we'll see how to begin with the drafting. So now first we'll place a square of base sides 35 mm resting on one of its base edges. So for that we'll complete drawing the top view of the square pyramid. So it is measuring 3.5 centimeters. So let me draw a square of length 3.5 centimeters. So this completes the base of the pyramid. Now let me draw the triangular faces, and that is completed by joining the opposite corners, that is by drawing the diagonals. So this completes the top view of the square pyramid. So this is the base of the pyramid, while these four faces represents the four triangular faces running from each of the edges. So we shall complete the annotation. So we'll annotate telling that it is resting on one of its base edges AB, while the other edges C and D. O is the apex of the pyramid, while O1 marks the center of the base of the pyramid. So now we will continue with drawing the front view. So for that, let us take up the projection lines from the top view. So from the corner A through the corner B, we will draw one vertical projection line. Similarly, from corner C and corner D, draw a projection line, and also from corner, that is the apex O, let us draw the projection line. So now the axis length is equal to 6 centimeters. So the axis is seen. So let us indicate the axis by the chain line. So this completes the axis of the pyramid. Now let us complete the pyramid front view. So let me mark the base of the pyramid by joining the two extreme endpoints. And next, from the apex of the pyramid to the end projection point, that is the base, draw the slanting edge. And again complete the other edge. So it is only the axis which must be measuring 6 centimeters and not the slant edges. So we will do the annotation. So for the observer who is looking from this direction, he will be able to see the corner B first. So B dash, and inside the bracket A dash. And similarly here the corner C is visible while D is not visible, so it is inside the bracket. This is O1 dash, while this is the apex O dash. So this completes the first view. That is, initially it is resting on one of its base edges. So now we will rotate the pyramid in such a way that it is resting on one of its slant triangular faces, that is AOB. So you can just see that O dash, B dash, A dash is this triangular face, which is not seen but seen as a straight line here, the slant line here. So it has to be rotated in such a way that it will be resting on one of its slant triangular face. So for that, we will just measure the length of this slant edge and transfer that on the reference line. So from a comfortable distance, just transfer this slant edge. So just remember that it is rotated. So O dash is this and this is B dash and A dash. And now to get the other base edge and the slant edge, what we will do is we will consider measuring the edges using the compass. So just measure B dash O dash to C dash D dash and transfer it here. So just remember, we will just do the annotation. So this is the apex O. So let me call this as O dash, and this is B dash A dash. So now from B dash A dash, I'm measuring C dash D dash, and I'll cut an arc. I'm going to place the compass here at B dash and D dash. I'm going to cut the arc, and similarly from O dash, I'm going to measure C dash and D dash. So this length of the slant edge. So let me place the compass at O dash now. So the point of intersection will mark the corners, that is C and D. So let me annotate this as C dash and D dash inside the bracket. So now let me complete the front view. So let me join this to get the base of the pyramid. So you can just see that the base is equal to 3.5. Because this is equal to 3.5, obviously this has to be 3.5, just 3.5 here. And next from C dash D dash to O dash. So with this, we complete the triangular face, that is the triangular face resting on the HP. We need to show the axis. So what we can do is we'll just measure what is the distance of the axis from any one of the reference point. So let me consider from B dash A dash and mark that point. So here it is somewhere around 1.9 centimeters. Okay, so if it is 3.5, it has to be exactly half of that. So it is somewhere around 1.8. So let me mark the point at 1.8. So now let me join the axis. Using the chain line, I'm going to draw the axis of the pyramid. So this point is O1 dash. So now let me draw the top view of the pyramid. So for that, I need to draw the vertical projection lines downwards. So from the apex, I'll be drawing the projection line. So before that, let me just draw the horizontal projection line. So from O, I'll be drawing this line. So this is the point of intersection. So this is O dash. And similarly, let me draw the horizontal projections of corners C and B. So from C dash and D dash, I'll be drawing one vertical projection line. And similarly from the corners B and A, and also from the center, that is O dash. And also one more horizontal projection line from D and E. So let me annotate the corners. So this corner is D and this corner is C. This corner, it has to be B. This is corner C. This is corner B, while this is corner D and this is corner A. So they get interchanged. AB here, so the AB comes here because it is rotated. So be careful, do not name this as AB and this as CD like you do it in the other problems. So here they change their positions. So now let me just complete this. So the base of the pyramid I'll highlight first, AB, BC, then CD, and then AD. So now let me just identify the farthest corner point. So the observer is going to look from this direction. So for him, the corner points that is farther is B dash and A dash. So now what I'll do is, let me first join the outer edges using the thick lines, that is the triangular face from D to O and then from C to O. So this one triangular face is visible to the observer. So since A and B both are the farthest corner points, I'll be joining that using the dotted lines. So A to O is a dotted line. Similarly, B to O is a dotted line, correct? So this is the axis. So let me just draw this as the chain line. So this is the axis and this point is O1. Well, this is the apex, just O, not O dash, it is O. So now you can just see that all the triangular faces, that is OCD is, the outer triangular face which is visible, whereas the base of the pyramid is visible, that is ABCD, while the triangular face BOC and then AOD are not visible to the observer. So it is done using the dotted lines. So right, so this is the first hint that we get, that it is resting on one of its triangular face, as you can just see here. Fine. So now you can just see the triangular face here, right? AOB is the triangular face on which it is resting, that is the top view. So now we have to go for constructing the third position, in which it tells that the axis is inclined to the VP at 45 degrees. So to measure that, you can just see here, initially the axis is measuring 60 mm here. So let me just indicate the dimension. So it is, equal to 60 mm. So this length of the axis is equal to 60 mm. But whereas when I measure the same axis over here, that is O1 to O, you can just see that there is a variation in the axis length. So it is somewhere around 57 mm. Okay. So it is not equal to exactly 60 mm. So it is equal to somewhere around 57 mm. So obviously the parameter has been changed. So let me just indicate the dimension of the axis that we're going to consider. So we have to go for constructing the beta angle. So now let us see how to construct the beta angle. See that in the first position, the axis measures 60 mm. In the second position, the axis measures 57 mm. So we are going to consider a parameter which has changed its geometrical dimension as the reference to draw the third position. So obviously we need to go for constructing the beta angle. And now we shall see the procedure to construct the beta angle. So first we shall make a note of certain parameters. So first, the given angle is phi, that is 45 degrees, and the initial length of the axis is 60 mm from the first position. And also from the second position, the axis measures 57 mm in the second position. So now we'll see how to construct the beta angle. So let me draw one reference line and mark one arbitrary point. And from this arbitrary point, I'll be measuring 45 degrees, that is the given value of phi. So it is here 45 degrees. And along this 45 degrees, I'll be first drawing a line of length 6 centimeters, that is the given initial axis length. So this is a line measuring 60 mm at an angle of 45 degrees. From the end point, I'll draw the locus line as a reference line parallel to the reference line. Okay, so this is O1 and this is O from the first position, and this line is called as the locus of O1. So now I'll be measuring O01 from the second position, which is equal to 57 mm, and I'll be transferring that here. So how is that done? So here you can just take a measurement, that is from O to O1, measure this, and then keeping your compass at O1, O, just sweep an arc like this. So this is the locus. So sweep an arc. So the point of intersection, you can just draw the line. So I'll draw the line. So from this point of intersection and to this point O, I'll be drawing this line. You get to see this. So this is O01 from the second position, and this is O1 from the first position. Okay. So now I'll be measuring this angle, and that will be the value of the beta angle. So let me keep the protractor at the reference point, and now if I measure the value, I'll be getting the value of the beta angle as 50 degrees. Okay, so this is how I can construct the beta angle. So beta angle is 50 degrees. So this is the apparent inclination angle. So now I've got the beta angle. So I'll consider one reference point. From the reference point, I'll be drawing the 50-degree line, which is the beta angle. So now let me draw this reference line, which is measuring 50 degrees. So never take the angle as 45 degrees because we are considering it the parameter which has changed its geometrical dimension, and also the word appears to be inclined is not given, so the given angle is phi and not beta. So on this 50-degree line, I'll be measuring this entire length. So what I'll do is I'll consider the dimension from this edge, that is AB, so this point to this apex. Okay, I'll be transferring that entire line first. So because it is the axis which is inclined and the axis is lying on this line, correct? So from this point to this point, it is measuring somewhere around 6.5 centimeters. So I'll be transferring the full length of 6.5 centimeters. I'll mark this. And next, I will transfer this points, that is from this point to this point, I'll be transferring that also. So it is somewhere around 1.3 centimeters. That is the edge CD. So 1.3, and also the point O1. So I can just measure that from this apex. It is 5.8 centimeters. So from this reference, I'll take 5.8 centimeters. So I'll getting the axis point here. So let me annotate, this is O apex and this point is O1. And I do know that these edges you see here, right, AB and CD, they are all vertical lines. So I'll just keep the protractor here at this reference point, mark 90 degrees line. Similarly at this point and 90-degree line. And I'll draw this 90-degree line for reference from the points. And also from this point 90 degrees, correct? So on this 90-degree line, I'll transfer the actual length. So it is AB. So it is equal to 3.5 centimeters only. So I'll consider the midpoint because it is passing through the midpoint. So 1.8 is the midpoint. So I'll place the midpoint at 1.8 centimeters and draw the edges. of 3.5 centimeters length. And similarly here also, I'll place the midpoint at 1.8 centimeters and draw a line of length 3.5 centimeters. And then I'll be drawing these edges. So again, they should also be exactly 90 degrees. You can use the set squares. So now let me annotate the corner points. The corner points is B, C, D and A. And then transfer the same triangular faces till the apex. And next, the hidden edges from A and B. So I complete transferring. So now let me just complete the front view. So that is done by drawing the horizontal and the vertical projection lines. So from the corner C dash and D dash, let me draw one projection line horizontal. Similarly from C here, I'll take up a vertical projection line. So this is one vertical projection line. Similarly, D is here. So from D, I'll take up one projection line. So I'll annotate the points simultaneously. So this is C dash and this is D dash. So A and B is on the XY line. So I'll draw the projection lines from A and also from B. So this is B dash and this is A dash. And also from O dash, I'll draw one projection line. And this is the point of O1. So this is O1 dash. O is the apex and the apex is also on the XY line. So this is O dash. Okay. So now for the observer, the base of the pyramid will be completely visible. So let me complete the base first. So the base is completed like joining all the edges using the thick lines. AB, then B to C, C to D, and then A to D. So this completes the base of the pyramid, which is visible to the observer. And now the farthest corner point is the corner D. So all the other edges will be visible. So C dash to O dash is visible. B dash to O dash and A dash is already done. It is the same straight line. And next from D dash to O dash, it is the dotted line because it is the farthest corner point. So in the pyramids, never assume the apex to be the farthest corner point. So the base of the pyramid is completely visible. And now let me draw the axis line from O1 to O. So this is the axis line, that is O1 to O, and this completes the manual drafting of the pyramid resting on one of its slant triangular faces. So it is resting on one of its slant triangular faces, that is A dash, B dash, O dash, and the base of the pyramid is completely visible. So you can just see the top view here and the front view here. So how do we validate? It is resting initially on one of its edges AB, and the same A dash, B dash is also there in the final position. So with this, we complete the problem. You can just indicate the directions of the projection lines using the arrowheads. So with this, we complete the drafting of the square pyramid resting on one of its slant triangular faces and its axis inclined at an angle of 45 degrees, but it appears as if it is inclined at an angle of 50 degrees. Thank you all for watching.